Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about one practical machine learning application. This topic is based on a tech blog titled The Evolution of Product Classification, written by the engineering team at Shopify. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Shopify is a commerce platform behind millions of merchants worldwide. It is founded in 2006 and headquartered in Ottawa. Shopify powers online stores, point-of-sale systems, and a broad ecosystem of apps and services that help businesses sell everywhere. Over the years, Shopify has grown into a publicly traded company with billions of annual revenue, supporting merchants of all sizes, from solo entrepreneurs to global brands. At the heart of the commerce lies one deceptively simple question: what is this product? That might sound trivial, but in reality, product classification is foundational. Correctly categorizing a product affects search relevance, recommendations, shipping rules, tax calculations, compliance, and associated analytics. If a product is misclassified, it can lead to poor customer experiences, incorrect tax handling, or even regulatory issues. As Shopify scales to millions of merchants and an enormous diversity of products, the needs for accurate, scalable, and adaptable product classification became critical. Manual tagging was not sustainable, and rigid rule-based systems simply can't keep up with the variety and constant evolution of the commerce. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. The team's developments in product classification can be understood in three clear stages, and each representing a deeper level of product understanding. Stage 1 here was a traditional machine learning-based baseline. Logistic regression trained on TF-IDF features derived from product titles and descriptions. TF-IDF converts text into numerical signals based on how informative words are across the dataset. This approach was simple, efficient, and scalable. It worked reasonably well, but it relied entirely on text. And in e-commerce, text is often incomplete, inconsistent, or sometimes ambiguous. This model had no visibility into product images, which are often the most reliable signal of what something actually is. Then it moved to stage 2. Stage 2 introduced a multi-modal model that combined both text and image information within a single architecture. This was a major improvement comparing with the stage 1 approach. By encoding the visual and the textual features together, the model can resolve ambiguity when one modality was weak. However, it was still fundamentally trained as a task-specific classifier. It learns to map inputs directly to Shopify's predefined taxonomy. But it did not develop a broader semantic understanding of products beyond that fixed label space. Then it moved over to stage 3. Stage 3 marked a shift toward vision language model. The key difference here is the depth of understanding. Vision language models are pre-trained on large-scale image text data and learn a shared semantic embedding space. Instead of simply learning input X maps to category Y, they learn richer conceptual relationships between images and language. This allows for better generalization to new or evolving product types, and makes the system more adaptable as Shopify's taxonomy changes. In other words, the model is no longer just classifying. It is building a deeper representation of what the model product actually is. Today, this architecture stands on two core foundations: the team's standard product taxonomy and a vision language model. The taxonomy provides a structured and consistent hierarchy that ensures products are categorized uniformly across the entire platform, which is essential for search, analytics, compliance, and downstream systems. On top of that, vision language model generate semantically rich embeddings that capture the meaning of products beyond rigid category labels. By separating the general product understanding from taxonomy-specific mapping, the team gains flexibility. This system can adapt to taxonomy changes and new product types without rebuilding everything from scratch, making the entire classification pipeline more scalable and future-proof. Of course, even the most sophisticated model must perform efficiently in production. At Shopify's scale, inference optimization is critical because millions of products may need to be classified, often in near real time. The team focused on improving embedding efficiency, optimizing model serving pipeline, reducing latency, and balancing accurate gains against infrastructure cost. A model that is slightly more accurate but dramatically more expensive or slower is simply not practical in a large commerce platform. So, by refining both model design and serving infrastructure, the team ensures that the improvements in classification quality translates into real-world impact without compromising performance or cost efficiency. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how Shopify evolved its product classification system across three major stages. From a traditional logistic regression model with TF-IDF features, to a multi-modal approach combining text and images, and finally to vision language models built on top of a standardized and evolving product taxonomy. We also looked at how architecture design and inference optimization are just as important as model accuracy in real-world machine learning systems. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.